One of the most powerful features of Revit when doing electrical design is linking in other trades models so that we can coordinate between the trades. So we can do some basic interference checks or clash detection while we're designing our system. So in this video, I'm going to show you step by step how to link in a mechanical HVAC model into your electrical model and set that up to see all their ductwork and their mechanical units so you can coordinate it with your lighting, with your conduits, and with your electrical equipment. So stick around for an exciting 3D lesson. Let's get right into it. So I'm here in my Revit 2024 in the Snowden Towers electrical project. This is from an ongoing electrical series that I'm currently producing that you can find on my channel. And in this lesson, as I mentioned, we're going to look at linking in the HVAC design so that we can coordinate with it in our electrical model. So the first thing we need to find is a mechanical or HVAC model that we can bring in. And I will also show you where you can download this Snowden Towers architectural model as well, so you can practice this on your own. Let me jump into my Chrome browser. So an easy way to do this is just to search for Autodesk sample projects. And then type in your version you're using. And in this one I'm using 2024, but you can find some in 23 also. So Revit sample project files. You click in here, and here it is right at the front. We're in Revit 2024, Snowden Towers. All of these files are available for free for you to practice with. They even have an electrical one, which if you like, download that, open it up, take a look. This is some other consultant that's done this, and we all do it a little bit differently, but you can learn a lot from examining existing models. But we're going to bring in the architectural and then also bring in the HVAC. You can also bring in the plumbing, and there's even structural you can bring in if you want to coordinate with that. So I've already brought in the architectural and HVAC from here. So back to my model. So I've already brought in the architectural model. It is linked, and if I go up to Manage Links, you can see that I have Snowden Towers Sample Architectural already loaded. Now what I do on my projects is I'll put the Revit version in the name of my file so that I can easily remember which version that's in to open it. But it's the one we just downloaded. So now I also need to link in the mechanical. So we can do this from here, we can add, or you can also just go to Insert, and then go on the left, link Revit. So we're going to link it in. We're not going to insert it. It's going to be a link. So it's just referenced into our project. So I store these in what I call XREF, kind of an old CAD name. And I'll go down, I have a lot of things in here, but I'll go down to Snowden Towers Sample HVAC R24, and what's important is where the positioning should be. Before I hit open, you can see I need all of these models to come in at the same reference point. Now, internal origin to origin will sometimes work for you, sometimes it won't. The most accurate way I found is to use the project base point to project base point. That is more accurate than the internal origin. There's about 4 or 5 different coordinate systems in a Revit project, including a survey point. So we want to use the project base point to project base point for the most accurate insertion. And it can be moved around once it's brought in. It's saying the following nested links will not appear because their reference type is set to overlay in the link. What that means is this HVAC has all of these other files already linked into it. So the people working on the HVAC design linked in the electrical and structural and everything like that to do their modeling, just like we are going to bring in their model. And so because they were set to overlay instead of attached, there's 2 different ways you can connect these references. It's not going to bring them as well, which is good. We do not need extra versions of these other files into ours. If we want to bring these in, we'll bring them in separately. So that is fine. It's just a little warning that they're not going to come in. So now, nothing has changed. I look at this, I don't see anything different. It could be different depending on how we have our view template set up. What categories do we have turned on in our model? And we are using a view template down here. So to get to these visibility graphics, we have to actually go to the view template. And in here, we can look at our model, the visibility and graphics and overrides for our model. This says which categories in our model do we have turned on and off. Now, if we look down here, we do not have ducts turned on. We don't have flex ducts or pipe. We don't have mechanical equipment turned on. We have nothing turned on in our model that's mechanical because we don't want in our production view. This is the view I'm going to drag onto a sheet. I don't want all the ductwork and piping and mechanical, everything showing in here. So I have it all turned off. However, I may want to turn some of that on for actual display in my model. So for example, I could turn on mechanical units in my plan so that I can see them and connect them. So if I turn on mechanical equipment, okay. Now these little guys show up, these little boxes. Now what is this box? If I just click on it, I'm clicking on the whole HVAC model. If I want to pin this model, which I should, let me pin this HVAC model so it doesn't move around. But now I can't select it at all because I don't have select pinned elements up top. Go ahead and turn that on for now. Now if I hover over a line of this and hit tab a few times, eventually there it lights up and I can click on it. So now I've actually clicked on the family within a mechanical model. Heat recovery unit, HRU, and it gives me some of the instance parameters. And I can even go to the edit type and look at the type parameters. Now I can't change these because they are part of the linked mechanical model, but I can look at them. So now I can look at this, maybe I'll get some information. They're saying it's 220 volt. They're saying it's so it's two phases, 2 pole, and 3600 per. Now maybe this is accurate information and maybe it's not. Depends on how your mechanical engineer or designer has set things up. In my experience, more than often, this is not exactly correct. And not saying they did it wrong, but what I mean is sometimes they don't know yet, and maybe this is an early model, they don't know yet that we don't have 220 available in this project. We have 208. I don't often rely on the information that I see in the mechanical model. I will go back to maybe a PDF set of their mechanical design, maybe look at their schedules, and even better, look at some actual cut sheets of their equipment that they provide to us. But the point is, some of this stuff is in here, and you can get an idea of what's going on here, but we know this is an HRU. It also maybe has a name. Now, sometimes it's in a mark number. Sometimes it's down here in a type mark, so they're not using type mark to identify. They are using the mark which they've done. So that's HRU 301B. And it looks like it's labeled, it's named after the room number that it's installed in. And there's 2 of them. So if I click on this one, again, I have to tab over this to get to it. This is HRU 301A. Now I know what they're calling these units. And again, if I want to make sure that's right, I need to look at a PDF copy of their design. There's only so much you can see in their model. I can't see any of the notes. I can't see any of their tags. I can't see any of that. All I can see is model elements. But this is a way to show up in our plan. Going back to how I did this, I controlled the visibility of that mechanical model within my electrical model. And the reason that works is if I go down to the Revit links overrides, where I see my 2 links, architectural and HVAC, and this reminds me that I would like to halftone that and underlay the mechanical model as well as the architectural model. But the display settings of that model are by the host view. Now, what's the host view? My electrical model that I'm currently in is the host of that link. I'm hosting their model link into my model. So I am the host. So my host settings determines what happens. That may work for you, and we can go with that. You can have tighter control if you switch this over to a custom view and then jump into model categories and go back to custom view here. Now I can control within the mechanical model whether things show or not. So you can go 2 ways with that. But for now, I'm going to leave it at host view, and I'm going to control it with my own categories. So in this production or sheet view, I'm going to want the mechanical units to show. Now, one other thing I want to point out here before I get further into this is if I want to connect this mechanical unit to my panels. So I have some panels already down. If you look at, for my previous episodes of this, I've shown down my parking level, I've got, main distribution board and some other panels down here that I can connect to. I cannot connect a family that's within a linked project. There's no connection point up here. There's no way I can connect this. Now, one option that people have tried to use is to copy monitor this one piece of equipment and then connect it. Now, you could do that. In fact, if I just do a copy monitor, for example, so I was going to go to collaborate and go to copy monitor. This is similar to how you would copy monitor grids from an architectural model or even levels, things like that. We can copy monitor things from other models. So I'm going to select the link and then copy, and just that one piece, and say finish. I'm done. So now I have their piece of equipment. Now, depending upon what connectors are in this family, because I have the HRU family in my model now, maybe I can connect it. And then I can go in here and change all of the loads to what I really want it to be. Let's say I found out it's 208 and it's a little bit different load. I can do that. Again, in my experience, these aren't always exactly how I want it. I don't want to have to enter a load for phase 1 and phase 2 separately. My preference is to have this set up as a balanced load. And you will see in my other videos about electrical distribution and settings that I'm very picky about how this works. So this is not set up the way I want it. So I really don't want to use their family. I don't really want this whole box to be in my plan. I just want a connection to this box to be here. Maybe a disconnect switch or maybe just some kind of a symbol. I don't need their family. So I don't go the route of copy monitor for their equipment. So I'm going to get rid of that. What I do is install just a connection to it. Now in my projects, I have a custom connection that I use, which is a two-dimensional symbol that has electrical connections to it. I'll show you that, but I can also show you an out-of-the-box way that you can do it if you don't have the custom families. So I have an ER equipment connection and I have ER motor connection. I have two different symbols. And so you can see I have a bunch of HRUs already installed in previous floors. So if I bring in HRU unit, you can see my symbol is a motor symbol with a disconnect symbol, and it even has a fuse in it. Now this can all be adjusted. I can turn off the fuse easily like that. I can go in and turn off the disconnect easily like that. So it's very versatile. This is our custom preferred symbol. I can click on this and I can hit spacebar and turn it around. The F turns too, which is annoying, but that's how it works. But I can do this and I can put this where I want. Let's say I looked at this unit and found out the disconnect's over in this area if I want to be that accurate, or if I just want to put it anywhere. But that's one way. And then this guy has an electrical connector in it that I can fully control. See how it has two poles in there? And so I only have one motor load. I don't have to put it in per phase. I also will give this a separate type that's called HRU 301B. So I will duplicate this and say HRU 301B. And then I also put that down because I use the type mark for my tag. 301B. That way, this unit has all of its own characteristics. And let's say we learned from that cut sheet that it's actually a 7,000 watt load, 7,000 VA. And I don't want to fuse. So there, now I have my own electrical connector in my model that I have control over, and it's set up the way I need it for my system, and I can connect it to a panel. So rather than using this custom connection, if you want to use out of the box, you can. Now there's a flaw with the out of the box connectors, which I'll have to show you. You will still have to do some family editing to make them work. So let's go to the insert load out of this family, and this is the cloud site where we can get to some out-of-the-box Autodesk families that used to be loaded with earlier versions of Revit, but now you just bring them in from the cloud. So you go to load cloud, and normally you see all results, and you can see there's architectural things, there's electrical, mechanical, structural, everything in here. If we narrow it down to electrical, you get both architectural type connections, which we do not want to use because they don't have the electrical connectors. They're just a graphic. They're just maybe a 3D box with a graphic. We can't connect them to our panels. So we don't want those. We want to use the MEP connectors. So MEP, and then it further subdivides all of these kind of families down into categories. So let's go to connectors. Now, if you look at the connectors here, you'll see we have electrical equipment connectors. If you hover over the name, you can see the entire name. Electrical equipment, if you recall, is panels. It's distribution equipment, so switchboards and transfer switches and generators. It's the distribution end of things. And then the electrical fixtures are devices, receptacles, motors, equipment connections, actual loads, or things that loads can be plugged into. We want fixtures. Now we have a balanced power connector and we have an unbalanced power connector. Now, if you watch any of my videos on power connections, you'll see that I describe the difference here. In loads, 99.9% of the time, you want a balanced power connector. You want to enter one load, like in VA or watts, and you want it to be dispersed equally amongst all of the poles or phases of that connection. So we're going to use a balanced power connector versus an unbalanced. So let's go there and load it into our project, into our model. Now you'll see it's over here, electrical fixtures, balanced power connector. So they give you a number of different voltages already set up as types, which is handy. We're going to check the 208 one, bring that in, and you'll notice right away that it won't let me put it anywhere. Well, why is that? Well, many out-of-the-box Revit families are what's called hosted or face-based. It needs a wall or an object or a ceiling or floor to even mount to, kind of like the receptacles. So this is a wall-hosted, placed on vertical face type of connector. Luckily, it sees this piece of equipment as a vertical face, so I can mount it here. But you will also notice it's a very tiny symbol. It's really just a blob. So let's put the blob over here, right there. That's all we get. No symbol. It's just a blob. But in this blob, we see we have a power button, so we can connect it. Now let's see what the data is. The instance parameters are not many. It's just mainly a level. But go to Edit Type, and we can get to the load classification, so we can change this to HVAC, which is good. The connector voltage is set up at 208, and it's set up as a 3-pole or 3-phase connection right now. We can change that as well. We can make it a 2-pole. But as you'll notice, there's no load. There's no load parameter. I cannot enter in how many VA this thing is. So frankly, it's useless to us. This out-of-the-box family, I hate to pick on them, but it's useless in this state right now, out of the box. If you look at the load down here that's grayed out, it's 0 VA, and I cannot change it anywhere. So even out of the box, we have to family edit to get this thing to work. It's a simple family edit, and it's a very basic one that I think everyone eventually needs to learn. So yes, in this lesson, we are going to look at how to edit this connector so you can actually use it. So let's go to Edit Family, and it pops us into this editor. Now, if this is your first time in here, you'll notice it's kind of set up like a project. It's got some views over here that you have to expand, floor plans, ceiling plans, 3D views, things like that. And right now we're looking at the 3D view of this thing. Now this big old piece right there, this monolith box, is an extrusion that acts as the surface that our connector gets connected to. So like I mentioned before, this is a face-based or face-hosted family. So in this editor, this is the future face that it will attach to. This big green with the X in it, and this is in a kind of an isometric view, is the electrical connector that we're going to talk about in a minute. But if we zoom in here, and it's hard to see, it's a blob. If we go to thin lines, we'll see that this connector is really just a disc. That's all it is. It's just a disc for that electrical connection. It's not a disconnect. It's not anything. It's just a disc, which is fine unless you're trying to actually model a big disconnect switch or a motor or something like that. You know, this is fine. But what we are most interested in as a 2D connection is what's in this electrical connector. So you click on this, And this is where we can see all the data associated with an electrical connector. Here's the balanced part that I was talking about. If it switches to unbalanced, you will see that we get separate apparent loads per phase that have to be entered. And we don't want that. We want this one load to be balanced amongst all of our phases. So that's why we're using balanced. We have number of poles. Is it lagging power factor, which is typical? Load classifications. We don't use this sub-classification. We've got voltage, apparent load, power factors. Now, some of these are grayed out. Well, what does that mean? Well, what that means is that I can't change it here because these are associated with, right here, associate family parameter. This parameter of voltage is associated with a, like it says, a family parameter. So there's a parameter created in this family that we can get to in our model. Remember, we could get to the voltage. We could get to the number of poles. And we could get to the load classification. If you click on this little button up here, family types, here's all the parameters, and these are the family parameters. We can get to load classification. We can get to that. And these are things that we can get to once this family is put into our electrical model. The one that's not here is load. So we need to add the load to this list of parameters that we can get to. The way we do that, again, click on the connector, apparent load, over to the right, this little teeny button, associate, and I call this mapping a parameter or associating a parent parameter. And there's no parameter popping up for this, so we need to create one. Down here, new parameter. And we're going to call this apparent load. And it comes up as a discipline electrical apparent power, and then which group do we want to group it under? As you recall, when we opened up that parameter list, there was a heading. Well, the heading we want is the same as the rest of them. And I think the heading was just under electrical. Let's go check that. It was under, yes, electrical. So now we have a parent load that shows up. And we can type in a default right now if we want. So let me call your attention up here to what type of load. Apparent load, we can edit it here as well. We have a type parameter or an instance parameter. Remember that a type parameter you have to get to by editing the type. If you change that parameter, it changes it for all of those instances of that type, which is what we want. I want to have a type for each mechanical connection because each mechanical connection could have a different load, could have a different voltage or phase. So I want the load to be part of that type, not an instance parameter. Okay, so that's all we had to do to edit this family. So we're going to load it back into the project. I'm not going to save this outside of my project right now. So I don't need to save this. It's still loading it, and I want it to overwrite the existing. So now I've changed the version that's in my model. I'm going to turn these thin lines back off. Now if I go into this guy and hit edit type, now I can get to my apparent load. Now I can put in, let's say it's a 7,000 VA load. It's 208, 2-pole, okay. Now you can see down here, electrical data is proper for this guy. And I really want this to not just be balanced power connector. I want it to have its own type name. So this one's going to be, like I did the other one, I'm going to call this one HRU 301A. This is the other one. And I use type mark for my tag. That's another issue, is how to tag this thing. But at least now I've got that in there. And a tag, let's see what happens when I tag this. Okay, I've got my custom tag. And so now we know that this little guy, even if you can't see it, is HRU 301A. And I can also tag this piece of equipment. Custom tag, you can see my videos on how to actually customize your tags. But now I can take this and I can actually connect it to my panels. So there's two different ways you can actually show the equipment connection. Now, so if you're getting some value from this video, I'd sure appreciate it if you hit the like button. That will spread it to other people who may need it. And also, if you want to see all of my other content and the future videos that come out at least weekly, then hit that subscribe, and I sure appreciate you supporting my channel. And thanks for watching. Let's get back to the video. Now, what about the rest of this mechanical stuff? Ductwork. What if I want to coordinate their ductwork with mainly with my lights, for example? How do I turn this stuff on? Well, what I use to do that is what I call a coordination view. And then down here in my ceiling plans, you can see I've already just duplicated my lighting view, and I call it coordination. What I do here is I will turn on ductwork and piping and things like that so I can coordinate mechanical with my electrical. Now, I've not created lighting plans yet, but we do happen to have some lights brought in from the architect that I can take a look at to give you the idea. But let's go ahead, and in this lighting plan coordination, I have a separate view template for coordination because I have different settings than I would for my production or sheet view. So let's go in here. We're going to use our host model to decide what turns on and off in our mechanical link. So in here, I do want all of these ducts and duct linings and all that stuff to show. I do want mechanical equipment to show. And I want the air terminals to show too, which is their diffusers. Okay, now what happens? Now, there we go. We've got some color in this thing. They use color in their designs. Now we can see we have our mechanical unit, but we also have these are ducts. Now, they're single line ducts, and what determines how the ductwork looks is the level of detail that this is set up to show. So if you go here, detail level, if you go up to detail level, right now it's coarse. Coarse is not, which means opposite of fine. It's just rough. It's very coarse. If I change the detail level of this entire view to fine, then I will start to get 3D views of things, including lights and receptacles and all of that. But right now I don't have receptacles turned on in the lighting view, of course. But now we can coordinate our lights with their ductwork. Now it looks like the architect did a pretty good job of laying these out to dodge the ductwork. But if I want to jump in here and look at this, I want to create, let's say, a 3D view in here. So to do my section box, I need something in the model. What I'm going to do is just install a light so that I have something to go from. So let's go down to my lighting fixtures and see what I have. I do have some light fixtures in here. I'm going to put a pendant circular in here and just put it at about 8 feet. And I'll put it nearby that light. This gives me something to click on so that I can go up here and do selection box. It's going to make a tiny little 3D selection box there. I zoom in, and there's my light. Now, what I can do is I can get a hold of this section box. Now, if you can't see your section box, if this blue doesn't show up, and we don't have a view template on this view, so I can go directly in here. If you go into here and go to your annotation categories, down here under S, you'll find section box. Right there. That might be unchecked. So check that, and that lets you make sure you can get a hold of this little blue section box. And this is kind of a magic box. You can just pull that, and it's just cutting a section. It gives you little grips in the middle of each side. So as you can see, now I'm starting to see all of my ductwork. And let's get this set up so that I can see a level 3 there. So kind of do that. And I'm going to pull this down just below level 4 there. So now I can see some of my ductwork, and I can start coordinating where things are. Now, if I hold down Shift and then push the mouse button, I can orbit and start seeing my room in 3D. So here we go. I can also change how this looks. Right now, down here under the visual style, it's hidden line, which is the default. I can change it to shaded. There, that's starting to look more realistic. And I can go to consistent colors, just some different coloring. Now, there's one called realistic, and it takes a long time to generate, so I'm not going to do that. But even shaded is typically good enough for coordination. So let's go ahead and orbit this around and kind of get into this room. Now, you can see this is the light fixture I put in, just a generic pendant, and this is the architect's light fixtures they have in here. But I can use this view to really coordinate some of the basic clash or interference detection of our models. You can see the mechanical engineer dove underneath the structure, underneath this beam. Now, another thing you can do here is if you don't like all these dark edges, we can turn those off as well. That is done over here under the graphic display options. There's a lot of different buttons to push, as you know. Under here, we have shaded, but so we can unclick show edges. That turns off those harsh edges. And then you just see the ductwork. Now we see these diffusers in color. But again, this can be used for coordination. And especially if we start drawing in any conduits or feeders. But this is the basics of how you bring someone else's model into yours and use it for coordination. And again, I do this in a coordination view. Another thing I'll say about this 3D view is every time you hit the section box, it rewrites your 3D view. So if I want to save this view, I need to name it because otherwise it's going to disappear next time I hit the section box. So let's go ahead and name this. F2 will do it. I'll just say 3D Studio Mechanical or HVAC to note that it's set up for HVAC coordination. And if I like this type of view setting, I can always right click and say create a view template from this view. And I can call this, and you can give it a custom name up front, which I do, ER, and I'll say 3D coordination view. And it's this one's at 1/8 inch. We can do it every scale we want. That way I can apply this and make sure that it's applied. There. Now, any other view that I have, for example, I have a 3D studio, which I've already done, or let's go back to the cafe kitchen that I've already done. If I want to do coordination views, I can simply go down to my view template, hit coordination, and there it is. Now, I can't see it yet because I haven't drawn this high enough. If I pull this up, I'll start to see some of the ductwork. As you can see, there we go. So now I can get in here and see my ductwork and make sure I'm missing it with lights and any feeders and such. But even in just 2 dimensions, it's very helpful to have this coordination view to help you as you design your systems. So I hope that's helpful to you. If you find this kind of video helpful, take a look at the one I have on the screen to look at next, and thank you for watching. Until next time.